The session will be on operational technology and cyber risk, security readiness for legacy and modern manufacturing. And first of all, for those who are, where this is their first session joining or they haven't used the tool yet, please take a quick look around the webinar tool, check out the chat, tell us where you're located, where you're joining us from. And just to note, we will answer audience questions during the session, so please post all your questions in the Q&A portion of the tool, not in the chat, as it'll make it easier for us to answer them. Before we start, a few things you should be aware of. Upcoming events from IoT World. On May 26th, IoT World will host Intelligent Secure Edge for Smart Cities. And then on June 8th, IoT World will have World Energy Day. This session will run for about 55 minutes and we'll have you out of here on time. It wouldn't be possible to run this virtual conference without the sponsors of IoT World. So thank you to Hitachi Vantara, HiveMQ, Siemens, Fortinet, Keyfactor, EMQ Technologies, K-Factory, OVC MBT, Trend Micro, Faircom, Nozomi Networks, LIM CMMS, Adolis, and Raven. Before we get into today's session, I'd like to tell you a little bit about IoT World. IoT World is the leading authority on industrial IoT. IoT World is a digital media outlet bringing the latest industrial Internet of Things, virtual conferences, and content to a global community of 279,000 plus decision makers and influencers. IoT World focuses on delivering daily insights on the industrial Internet of Things across multiple verticals. Online, IoT World curates a series of virtual events that punctuate the calendar and draw thousands of delegates, including IoT World Days. So with the housekeeping out of the way, I'm very pleased to introduce our topic and panelists. So the topic today is operational technology and cyber risk, security readiness for legacy and modern manufacturing. Our speakers today, joining us are Martin Diaz, Director of Operational Technology Alliances at Fortinet. Martin has 22 years of experience in industrial control systems, process automation, and OT security consulting, with past roles at GE, Schneider Electric, and NTT. We've got Rakesh Dodeja, Principal Engineer and Senior Solutions Architect at Intel. Rakesh has been with Intel for over 22 years, focusing on system architecture and IoT solutions. Rakesh defined Intel's IoT device system architecture and led the engineering team for Intel's secure remote management and secure device provisioning and onboarding capabilities for IoT. And we have with us Paul Brownlee, North American lead for OT cybersecurity at Accenture. Paul has worked with Accenture for 6 years, focused on OT cybersecurity. Previously, Paul was with Shell, where he led their ICS security capital projects and advisory services. So welcome, Martin, Rakesh, and Paul. And I'm going to get us started on our panel discussion. So our first panel question is, what type of transformation initiatives are driving change in manufacturing? So what is driving the change in the manufacturing environment and in the network that people have to secure in the manufacturing environment? And I'm going to start with, I believe this one's for Rakesh.
Okay, so I hope you can hear me. Good afternoon, good morning, good evening, wherever you are. And I'm going to start talking and give you some brief on the first question. So today, most manufacturers have a desire to connect the unconnected factories, right? There's a lot of solutions out there offered by cloud service providers, which help take the advantages of AI, analytics, insights in the cloud, and cheaper on-demand compute and storage, which is available from these CSPs. With very little price, you can actually access them and get your analytics done. There's also the Industry 4.0 initiative led by the Open Process Automation Forum, and it brings an increased flexibility in manufacturing with IT and OT integration. The solutions are built on top of newer architectures with capabilities like workload consolidation with virtualization, secure remote device onboarding, solution deployment with capabilities of lifecycle management, with microservices-based orchestration of workloads. But a lot of organizations do not want to send their data to the internet and to the cloud, just because they're not sure how secure and protected their data would be. Martin, you want to take next?
Yeah, Martin or Paul, if you want to jump in, please.
Yeah, I just wanted to add, and thanks, Rakesh. Really what we see from our perspective is a specific initiatives under the smart manufacturing or digital transformations, as Rakesh mentioned. And I will say that lately, what we have seen, some asset owners are heavily investing in 4 major areas. One of the first one is, as Rakesh mentioned, really trying to integrate into business systems and applications that might require to make their manufacturing operation more agile. The second is putting a lot of emphasis in predictive analytics. We have seen a lot of investment into kind of a digital twins simulation tools, where they wanted to really simulate the most critical part of their processes. The third one, which is more relevant to this conversation today, is around security. They are trying to really understand what is the security posture, what are things that they need to do, do they understand, have a comprehensive asset inventory, do they have a good security strategy, and most importantly, what is kind of the longer term roadmap that they wanted to put in place. And lastly is, what we are living, everybody in the world today, remote access, it has been a major area where people are trying to focus on how do we provide secure remote access into not only into the corporate world, but also into the manufacturing world. And the use case for remote access into the manufacturing world has very specific requirements, and sometimes the IT solution don't necessarily satisfy the requirements of the OT stakeholder. Thank you, Rob.
Should we move to the next one? Can't hear Paul.
Yeah, we'll take a poll right now while Brad is coming back in.
Sorry, I had a video showing back. I think we can move to the next question. Sorry. Our next question is, what kind of security gaps are manufacturers managing given the increased level of integration and corporate network connectivity? And for a lead off on this one, I'd like to go to Martin, please.
Thank you, Rod. And as I was mentioned before, the increased usage of new technologies like cloud, data analytics, machine learning, and especially IoT platforms, among other interesting solutions that customers are deploying, is really creating additional attack surface for attackers to kind of piggyback in. And that really creates a lot of potential and negative outcomes. As we know, a potential attack into a critical manufacturing might have a lot of outcomes, such as loss of production, personnel injury, or even loss of life, and in some cases, catastrophic impact to the environment. I will say that looking into the specific apps, IoT is one of the areas that people not necessarily look into, but we believe that that's really a major driver that can actually create potential security issues. As we know, IoT, in many cases, they don't have a very strong, robust security controls in place. And the important part is that they provide the connectivity with the manufacturing plants. So meaning that they are actually the bridge. And so attackers, if they compromise one of those assets, they can quickly move down laterally into the manufacturing network. In addition, the other thing that we have seen kind of a gap, asset owners, they are extending the network infrastructure to remote areas, and they are increasing sensing capacity because they need to kind of satisfy mobility requirements that the mobile worker has nowadays. This is another gap that in many cases, because security controls are not necessarily applied to the remote sites, exactly the same way that they are deploying the main locations. And that really, gives a lot of possibility for attackers to kind of, piggyback and try to exploit vulnerabilities into the remote assets.
Thanks, Martin. I'll continue with this. So additionally, very important to understand is security knowledge is very specialized and experts are hard to find. And most organizations have to depend on few internal folks or external organizations who can help and manage and keep the operations running. So IT teams are also very challenged with daily new attacks. New information on new vulnerabilities is published on a daily basis, right? And on the other hand, manufacturers have legacy systems which are deployed many years ago, right? And some of them may be running older software, hardware, older firmware, right? And these legacy systems, need to be updated to address the gaps and weaknesses, vulnerabilities, right? and to reduce the risk of interruption. Organizations may have to use firewalls, they may have to isolate and air gap the networks, block physical access to the ports, and most of these operations of managing security are manual and are expensive and require truck rolls, right? And they're time consuming. So everything has to be kept into the perspective before an integration of IT and OT can happen.
And Paul, do you have any thoughts on this this issue of security gaps in OT or ICS?
Yeah, I think if the question is, what security gaps do manufacturers have today? In the legacy environment, we have all. I mean, absolutely everything. I mean, we've done. We have poor network separation and segregation, as Rakesh and Martin mentioned. We have almost no patch management in a lot of cases. We've got outdated software. We've got just a lot of legacy stuff. We're managing this on the 20 or 30-year cycle that the piece of equipment that the digital assets are attached to. We're managing on that life cycle, not the life cycle of a computer that we would typically in IT. So it's been brought on by just poor life cycle management over the life of all these things, and their general lack of hygiene of the digital systems attached to those physical assets. So I mean, it is everything. The gaps are all over the place.
Yeah.
Okay. I think we'll move to our next step, which is going to be an audience poll. So there's no right answer here, by the way. What intrusion or what source of intrusion is creating the most risk to your manufacturing or production environment? And this is in your opinion. Interested to see what you view from your organization. Okay, we'll give it a moment here. While we look at that, I think we'll move on to the next question. And the next question's on sort of on the same topic. What do you view as the major cybersecurity threats impacting manufacturing or putting production at risk? And for this, I'd like to go first to Rakesh.
Yeah, so any hardware or software malfunction, can bring down the production line. With factory automation today, all manufacturing happens in a robotic setting, right? You have a lot of automation, controls are automated, sensing, and the cameras, digital cameras, right? However, the existing implementations, right, brownfield implementations, do not have an efficient way to manage the deployed systems, the lifecycle management, as we heard earlier already, right? The solution updates to change the manufacturing line. For example, you want to change a model of a component or a little bit change is a long process, right? And then you also have to address security threats, right? They're all manufacturing manual processes, right? These manual processes are open to insider attacks, and sometimes the device can be stolen because you are using, older legacy software, password and user login and all that. Sometimes you have same password and same login for all nodes, right? And this is the biggest problem, right? A device can be stolen, and your password and ID is now available to the hacker community, right? And these attacks, right? Someone gets access to your device, and then it gets into your production line, gets into your operation, and completely brings down the production line, right? And this is a serious problem, which is a major threat. So, and then the IT/OT organization also have to keep a watch on the information of various vulnerabilities and zero-day attacks, which are published by the media and security forums, right? So they have to then, and they have all got the potential to bring the production line down, right? And the IT organization has to put in resources to address these issues which get listed. Intel and our partners, Fortinet and others, bring a variety of security capabilities, right, in current and future offerings, which help mitigate most of these security problems. And if needed, we can actually post some information of what we have to offer.
I'd like to turn the same question to Paul, if that's okay next. If you have thoughts on what you view or what your customers view as the major threats to their manufacturing environment from a cybersecurity perspective.
Yeah, so we've got I mean, there's lots of threats, obviously, and especially these days, we talk about nation states attacking. The actors are sort of everyone, and that's whether we're attacking critical infrastructure in an attempt to disrupt, or whether there's a financially motivated attack or fame or whatever it is, right? There's a variety of tactics and techniques that are being used in the space, of which I'm sure that the poll that just came out is going to say that ransomware is one of the big things, and obviously that's just one tool in a larger toolbox. I think a lot of the threats we don't even know yet, right? There's a lot of things coming at manufacturers at the same time, and with all of the sort of poor controls that are in place that we mentioned a little bit earlier, there's a lot coming.
All right, I'll move us on to our next topic. So the next one is on, I guess, on risk to the environment itself. So there is, you can, I guess, in terms of securing a system, you can spend more and more money to make it more and more secure, even as you connect it, even as you bring greater connectivity. But looking at the other side on the risk tolerance of manufacturers, in manufacturing, how do you view that kind of calculus of risk tolerance within manufacturing? And I think we're going to start off with Rakesh here.
Yeah, so manufacturers are very concerned with the recent rise of ransomware attacks, right? We believe it's a very costly problem to deal with, because the way it works is someone connects to your system, gets hold of your hardware, software, and encrypts the hard disk itself, and then asks for ransom. Unless you give the ransom, they don't decrypt or make it back available to you. And so not only your production is stopped, right? All your data or IP is at risk of getting stolen, because those guys are in control of it. And then to get out of it, you have to pay to mitigate, right? So manufacturers are paying a lot of attention how to mitigate this. They want to build and deploy solutions in their manufacturing settings so they are very secure and protected. One immediate requirement which has bubbled up, like we are actually working with some of these oil and gas and industry, manufacturing industries. And they have basically said, oh, we want completely air-gapped, isolated deployments. The systems, which are the production systems, cannot be reached from the internet, right? And that's what air-gapped is one of the kind of solutions being thought about, right? And of course, additional deployments of firewalls, segmenting the networks, help isolate the portions of the manufacturing to reduce the risk. No organization wants to be in the news because they were attacked and the production went down, right? This is a pretty, kind of a very sad situation if someone gets exposed like this. And everyone is building their own proprietary processes and methods to protect themselves, right? We'll talk about some of the security standards in the manufacturing settings in one of the later discussions. Paul and Martin,
yeah, if Martin, if you had any thoughts to follow on those.
Yeah, I will start by saying that it's advisable that manufacturing organizations, they might want to define what I call an acceptable risk level, and typically they will get to that by performing a risk assessment. The risk assessment will help them to determine what is the potential, safety and hazard issues, and they can actually prioritize which ones they need to tackle first. This acceptable risk should be defined by the whole organization and potentially approved by senior management. The main reason is because having a comprehensive risk assessment and understanding all the risks that you have, especially coming from cybersecurity, will enable you to define what things and controls that you need to put in place first. To give an example, a lot of organizations, they'll rather, if they have an attack, they'll rather have the attack to be contained by other security control, like for instance, segmentation. And they cannot necessarily shut down the process right away just because there is an incident. They might need to shut down the process in an orderly manner to a point that they can bring to the system into a steady state. And after that, they can take care of the issue. And we have seen people using basically defensive approaches where they have a lot of different controls in place, and they are trying to use the controls to make it more difficult for the attackers to get into the what they call the most critical assets. So that's really, going back to the risk assessment, make sure they understand and they accept the risk properly. That's what I will add to this particular question.
Got it. And I just love your perspective, Paul, as well, from your experience and your customers.
Yeah, and maybe I'll build on what Martin is saying there. I think, in reference to how much manufacturers are willing to tolerate when it comes to availability and safety, I mean, very little. But they very rarely understand what the risk is, because cybersecurity teams don't necessarily equate those to terms that the business can sign off on or not sign off on. So a lot of the time we have risk that hasn't been defined that's sort of accepted by default. And so when we talk about safety and reliability inside of these companies, they have great numbers that tie that to the probabilities and the impacts and all of those things. I think our job as cybersecurity professionals is to marry those impacts that we do understand well. We understand what downtime means at individual sites for individual units or for different processes, and then marrying those things with what we know about the cyber landscape and what we know about the threats and what can happen and what's feasible in certain scenarios. That's the job, and that's how we need to be communicating up to senior management so that they can make informed decisions and make real investments in this space that can address real risk.
That makes sense. All right. So before we go to our next topic, we have our poll results from our first poll. In the lead, winning the Kentucky Derby of threats here today is ransomware and phishing, which is very unsurprising for anybody who follows the news. So I'm glad to see everybody's following the same news that I do. The other one that pops up is insider breaches, so unintentional or bad actor behavior from inside the organization. And then people look at hacking, so hacking against sort of generic targets. And then I guess in fourth or fifth place is removable storage. So people have a view of all these risky behaviors in kind of the same stack up that I would probably give them. All right, so moving on to the next topic is going to be another poll. And this one is on protection strategies. So what primary strategy or technology are you using to protect endpoints in manufacturing? And we've got traditional antivirus, whitelisting and application control, network segmentation, endpoint detection and response, OT intrusion detection systems like our sponsor Nozomi Networks or Clarity or Dragos. None of the above, all of the above, don't know. I hope nobody says none of the above, by the way, but we'll give it a few seconds with people to look at these. All right, so I'll move to our next topic and then check in on the results of that. So the next question is on applying network segmentation principles. So we know that a lot of, at least the legacy environments and some of the architectures from the automation vendors require things to be relatively flat from a network perspective. So how can we apply network segmentation principles into these kinds of networks? And to lead off, I'd like to go to Martin, please.
Thank you, Rod. We all know that segmentation, and especially micro-segmentation, are very effective security controls, and in many cases help to contain and approve access into any kind of networks, really. The issue with flat networks is, how do you take a flat network to apply segmentation, proper segmentation controls? And in many cases, we know that a flat network is literally everybody's on the same subnet for the most part, just to make it very simplistic. Which leads to, if somebody just plugs their laptop or a USB memory into a infected USB memory into a computer, effectively this is going to transfer across the whole subnet or the whole network. So how do we contain that? And in many cases, depending on how the network was set up, there is a need to reassign devices into different zones as you applied basic principles of segmentation, which is look at devices that have similar security requirements, try to put them into specific groupings. And many times we find that devices might need to be, we might need to change the IP address of the devices, which really in a manufacturing environment creates a lot of issues because it requires a lot of effort. The device might be too old, it might require special software to change the IP address, or maybe the expert is not available any longer. So that's kind of a major roadblock. But going back to the principle, in some cases used by installing a device to divide the IT from the OT, and use that device then to start doing a proper flow analysis, really understand what's coming into the OT network, and then try to go from what I call basic to excuse me, to middle to better segmentation, where you can kind of take the application to kind of a journey, and you can start assigning specific apply specific segmentation requirements. Obviously, the next step will be to really move into a full micro segmentation and application control. That's kind of, in my opinion, when customers have a more mature application, they really understand their environment, they understand completely their baselines. That's really going to be helping them, because with that, they can accomplish what we call east to west traffic monitoring, and they can start really embracing, standards like the 62443, where they can define their complete zones and conduits, and they can start really tighten down their flows to only assign specific jobs to the people, to the things that they need to do to the network. So,
Yeah.
in summary, that's kind of what I see.
Yeah, and I'd like to go to Paul next, and then there's a related question from our Q&A that I want to jump in on as well. So, Paul, your thoughts first on applying network segmentation principles. Like, what do you see out there when you're implementing this stuff? Yeah,
and look, so much of it is basics. I mean, in a flat network, there's so much low-hanging fruit, and we can look to models like 62443, zones and conduits, and get great guidance on those things. And those things are easy to say and hard to do. A lot of these networks are completely flat, and there's also completely unmanaged switches, and we have 9-month to 1-year lead times to even buy switches. So it's easier said than done to do a lot of the things that we're talking about here. But I mean, we do get a lot of benefit from them, and those benefits are more than just cybersecurity. We have enormous infrastructure challenges in our operations. We have all unmanaged switches on a flat network in a manufacturing site that's the size of 2 football fields and runs a variety of different processes and churns out a variety of different products. They're having some enormous infrastructure issues there that improving the security and the architecture would almost certainly improve the operation too. So looking for places where we have things like east-west monitoring that Martin mentioned, that's great. Things like that can give operations additional value and additional visibility and that sort of thing. And we can look for opportunities to do things like that. But to go and take something that isn't segmented and segment it is a disruptive activity. And so we need to look for where the value is for that. And it's more than just security. There's tons and tons of value. But making that case and explaining it to operations and bringing it to them in a way that it's executable is the key.
Got it. Now, a related question came up in our Q&A, I think, which is, or at least a little tangentially related. This question is on deployment of IoT devices. So if people have already rolled some IoT devices into their environment, are there steps they can take to ensure that doesn't introduce a security risk? And is that more, I guess the question maybe 2 parts. One part is, if they've got an IoT device, are they looking to somewhat keep them segmented off from the rest of the manufacturing systems? And or might they be wondering about the security architecture of the IoT devices and how that might differ from the traditional manufacturing stuff? So I don't know if, not to put anyone on the spot, but I'd like to just ask Rakesh for his opinion on both the IoT architecture and then also how you secure an environment while introducing some of these newer technologies.
Yeah, so I actually started working on this kind of problems maybe more than 10 years ago. 2010.
That's the right person. Perfect.
Yeah. So the first, we call it Moon Island, right? IoT gateway. First, we used to call it a Swiss knife of all gateways. It had multiple network interfaces, Ethernet, modem for cellular connectivity, and also a LoRa or 802.5 or 11, one of those, right? Low bandwidth networks. And exactly one of the questions was, how do you secure these devices? And we made a mistake of actually locking it down and the beginning itself. So we used to put Wind River Linux software on it, right, and lock it down completely with iMac, something equivalent to SE Linux with no password and only remotely accessible and all that. It was too early before it's signed, but now that is what people are doing. So you don't have any logins on those devices. You basically lock them down and completely purpose them for the use you want to, and then start using them. Right.
So
That's
it
one of
sounds
the
like,
approaches.
yeah. So it sounds like that approach is actually on the architectural level of the IoT device deployment or the edge deployment, is to start with a better security architecture for that part of the system.
Yes. Today, if you see iPhones, they're completely locked down. You just can't get into them. And it took maybe 7 years for Apple to do that, right? So you can imagine how complex this problem is.
So going back to, I'd like to just bounce back to Martin, maybe on the question of segmentation there, or how segmentation and other technologies might be used. If you've brought in, or you're going to bring in some IoT devices that are maybe just doing pure data collection, and bringing it up for analytics, do they need to talk to the manufacturing system? Are there ways of keeping those separate so that you don't introduce vector into your more critical environments?
And Rod, that's a great point that you are making, because one of the first things we try to do is to look into what is the function this IoT or sensor is going to perform. Is that requires a control, meaning that it will be connected to a controller that will have to take an action on the input of the IoT device, or is used for data collection? And so that's kind of telling us if obviously it will be used for control activities, it will have to be connected to the control network, especially where the PLC or the controller is located. If just for data collection purposes, and even though that's on the OT side of the shop floor, it's advisable to potentially place that on the IT side or the manufacturing network. As you know, we are dealing with, in many cases, kind of a 3-tier network in this environment. At the very top, we have the corporate network. In the middle, we have what we call the manufacturing network. And at the very bottom, we have the control network. So it's critical to really understand the function and place the device in the proper location. And once you have the device in the proper location, use the outcome and then the proper segmentation to define the limits and the proper security that have to be applied to the device. That's kind of a very basic criteria, but that's seems to work in some specific and critical environments.
Okay. Shall we move to the next question? I think. Yeah, so let me take the lead here, right? So the question is, how do we address the fact that manufacturing systems are not upgraded or recycled, every 3 to 5 years, like the IT systems? Our laptops from the IT department are, upgrade every 3 years, but the manufacturing systems are not, right? So what challenges do you have to overcome for security, given the age of your equipment? Most do not have security designed in, right? So as I mentioned earlier, manufacturers are upgrading their deployments to be able to better lifecycle manage their devices. And what I mean by lifecycle managers, from remote, you need to be able to update the firmware, operating system software, even the application software, right? So that your end-to-end solution is kept up to date, patched with latest builds of software and firmware. Older systems were designed to be managed with physical access, right? If some update used to be required, someone will carry a USB, plug it in, and do a BIOS update or a software update. And with new requirements, there is zero trust from anyone, insider or outsider. The IT and the OT for these devices, Martin was mentioning at the various layers, are completely locked down. They have to be remotely managed. And as long as they are performing their functions, you cannot do any updates. So all of them, need to be kept up to date. And because, as I said earlier, right, vulnerabilities and, threats keep coming on a daily basis. So you may need the updates on a daily basis. Something like what you see today on your laptops will have to be done on these devices. So that requires an additional challenge, right? Your architecture needs to comprehend ability to be highly available. And if one node has to be taken down for update, the workload, whatever application it is running, needs to move to the other standby device. Some of those capabilities have to be required to be building. And then from the security perspective, we mentioned earlier 62440 standard, it actually allows different target levels of security, right? And some of them may be better suited for your kind of manufacturing. Others are still higher levels of security for other, defense and health kind of use cases. But this standard has a long list of capabilities you have to support, and other two, and the industry are building devices which comply to this standard, so will be interoperable.
Thank you, Rakesh. Thank you for picking up the ball after I was unceremoniously dumped there for a minute.
Yeah.
I'm just going to bounce back to our previous poll results. So I'm pleased to see a lot of the largest group of people are using or hoping to use all the technologies that are mentioned. And out of people who are mentioning specific technologies, we see traditional AV and endpoint detection and response kind of related technologies being heavily used, network segmentation, and then coming a close third or fourth were the OT intrusion detection system. So it's good to see. I guess we've got a fairly mature audience from a cybersecurity perspective here, so they're using a lot of these capabilities. That's great to see. Following on to what Rakesh mentioned about the legacy and modern equipment problem, I think we'd like to go to Martin next and just discuss a bit further.
Yeah, no, one interesting part is that as you look into what I call the pre-era of Windows NT, so we have devices with preparatory operating systems, mostly 30, 40 years ago, designed, engineered around that time and implemented. And then, in the last 10 years, we've been seeing a lot of new technology with what analysts are calling cyber physical systems. Basically, automated robots or things that are completely integrated and are capable of adapting to specific disruptions because they are connected, built into integration with different systems. And really, one of the things is so how do we kind of go about, because in many cases we have use cases where in the same roof they coexist the two types of equipment. So we have customers with a variation of equipment, a legacy AGS as well as multi-vendor environment. So one approach that I believe has worked in different environments is to create kind of an inventory of all the assets and try to group them in different groupings to really understand their security concerns, and then again moving down into creating segmentation, but most importantly is to really understand how those devices will interact and the hardening the devices might have. For instance, the legacy devices, the security was built on top after they were installed, and the new devices have very complete different hardening. So it's really looking into the basics and the overall cybersecurity hygiene, and really try to lock down the devices to a level where the manufacturing use case will feel comfortable with using those devices in place.
Yeah, thanks, Martin. I'd actually like to I'd like to weave in one of the questions that just came up, which was minimizing risks from legacy devices with older operating systems, like prior Windows versions, out of support Windows versions, older antivirus versions that may not even be supported yet, or anymore rather. And our question comes from Juan Laredo, and he actually points out that many sites just virtualize the older stuff on newer Windows 10 or 11 hosts, but the underlying the virtual machine is still running this out of date or unsupported software in various ways. So, and maybe if you don't mind, Paul, if you've encountered this, what are some strategies people can take to, I guess, if you're maybe don't take it as given that people are stuck on these older versions, but assuming they want to keep running an older version, what strategies can they take to mitigate those risks a little better?
Right, and we have seen this, and certainly seen it in pharmaceutical industry, and in industries where we have systems that need to stay fixed for a variety of reasons, and certainly, you know, the way that we manage these things, legacy systems in general, we're managing risk. I mean, not every control can be applied to every situation, and not every system or piece of equipment has the same level of risk. So we have to manage that risk, and a lot of the time we have to use mitigating controls. So an example on a legacy host like that would be
Last time.
All right, unfortunately, we may have lost Paul's audio there for a minute. So we may, oh, Paul, I hear you coming back here. So we lost you for about 30 seconds if you want to dive back into your answer.
Right, an example of where we would see something like this, we can use whitelisting or allow listing as a, versus a traditional patching strategy for an outdated host like that. So there's compensating controls or mitigating controls that we can use for for certain ones of these one-off situations where we might have an issue like that.
Sure. Okay. All right, I'm going to move to the next topic here, and this one is on what people can do. First of a couple questions on what people can do to mitigate risk. So, what strategies do manufacturers deploy to mitigate risk to manufacturing? And we're going to go right back to Paul to lead off this question. So, what do you see people deploying to mitigate risk, cybersecurity risk in their environment?
Yeah, so it's a variety of things, and I think there's and I apologize, my power has gone out at my house, so I've got an unstable internet connection, so I apologize if I drop. But at the end of the day, there's a variety of different things that folks are using to.
Hey, Rob.
Yeah,
I can follow up on this question.
yeah,
And,
Martin, why don't you take that for a minute while Paul tries to get his generator fired up. Everybody see the woes of live broadcast, folks from home.
Right, apologies for that. So one thing we have seen is really as Paul mentioned, there might be a different kind of strategies, but we can actually group them in two different categories. The first one is kind of a passive defense. This passive defense strategy is really looking at securing, protecting, and defending against kind of a low to medium complexity attacks. And really, the main goal is to use layered defense and defense in depth and kind of a security approach. And that's really helping with that is deploying traditional security controls, including like perimeter protection, network access control, segmentation strategies, along those lines. When we look into more active defenses, when customers are trying to anticipate and try to understand what is the behavior of the attackers and how can we put controls in place to help us to understand that. And they're really mostly focusing in monitoring, managing, and sustaining the overall OT security posture. And they are doing that by deploying tools like deception technologies, anomaly and breach detection, as well as real-time threat detection. And in some cases, this analysis is helping them to be more proactive and to really get ahead, or at least try to get ahead of what attackers might be planning to do, with the goal to reduce the time to response. They are really trying to understand how can we mature our security to a point where we can be more proactive and we can have a very well-defined security playbooks and respond quickly with our incident response plans.
Very good. And Rakesh, do you have anything to add to that in terms of what you see people deploying? Oh, Rakesh, you're still on mute. Sorry.
Yeah, I'm back.
There you are.
Yeah. So yeah, as I mentioned earlier, right? So and my thought is something much earlier, right? Upfront. Before a manufacturing organization decides to connect the unconnected, right? They need to go back and audit their current brownfield setting, right? Develop strategies to update their hardware, firmware, software, application to the latest, and bring secure remote provisioning and onboarding, right? to be able to remotely lifecycle manage and orchestrate their applications, right? And there are organizations which help with this audit, right? And recommend additional security products which can be added to the infrastructure before you go online and get connected, because connecting will open the floodgates to attacks. And if you are vulnerable, you're likely to get compromised and attacked, and you don't want to be in that situation.
Okay, so it sounds like you're
yeah.
you're talking about kind of a hybrid of bringing in some more modern architectures and securing whatever legacy architectures you have.
Yeah, because like even if I bring in something at my home and I want to connect, I want to make sure that it's not going to bring in some malware or something into my network. So you have to kind of be very careful before you connect.
Okay, I'm going to move to our next. Question here, and this one I think we're going to. It looks like we're having trouble keeping Paul on the call, so I might have Rakesh lead it off. So as you look ahead, what are your top 1 or 2 must-haves for the security strategy, the cybersecurity strategy that you would recommend for manufacturing?
Yeah, so all organizations have intellectual property for designing and building their products. They want to protect them, right? And then there is a lot of value in understanding the value of your data, right? And then protecting your data. So you need to protect your IP, you need to protect your data. And security is not just one time or one thing, right? You have to continuously keeping track of your software, what are you using, and then are there any vulnerabilities uncovered about on the software you're using, either from open source or from a vendor, and make sure that you have your support process and support plans in place, and you can get them patched and updated, right, as new vulnerabilities become available. And the recommendation is also take advantage of the new hardware capabilities, hardware suppliers are making available. With, of course, adding additional software, artificial intelligence, analytics, automation, and standards. Standards are very important, right? Because standards are being created by multiple players in the community, right? And people learn about their problems and go back into the standards organizations and recommend inclusion of the capabilities and addressing those problems which they have encountered, right? And again, now you are between the cloud and in the on-prem. If you are comfortable in protecting your IP and data while it is created, used, stored, in motion, at rest, right? You can go to the internet service providers and use them. If you are so concerned that no, you don't want to let your data out of your firewalls, then you are, better doing everything on-prem.
And Martin, if you can comment quickly on this, and then we'll move to a few Q&A sessions before we reach our time here.
Certainly, I will actually offer three kind of suggestions. The first one is really going back to the basics and try to tighten the overall cybersecurity hygiene, really harden the basic, especially for legacy devices. The second is get an awareness of the overall visibility of the environment, really understand what we have in our network, kind of build a baseline, as I call it, of the normal operation. And based on that, look for parameters that are outside of that to properly investigate as well. Lastly, I will say that raising awareness across the organization of potential cyber attacks and what potential countermeasures could be applied. This can greatly reduce unwanted errors and shorter time to resolve problems. At the end of the day, cybersecurity, especially in the OT environments and manufacturing, is all about making sure that we are considering people, process, and technologies to properly define a comprehensive cybersecurity strategy.
Great, thank you. I'm going to move on to a few of the Q&A questions. So we've got a few from our session. I think you may be able, our panelists may be able to open the Q&A tool to sort of preview what people are asking. And somebody who was very patient, they asked their question at 12 minutes into the session, and I'm only getting to it now, so thank you. Had a question on using VPN to remoting in. So they're asking really about secure remote access, using a VPN to remote into a PC that then remotes into another machine the sort of VPN to jump host approach that we all know and love seems archaic. Are there more secure ways to accomplish this? If somebody wants to look for a current or more modern approach to secure remote access, what can you discuss that might be available to them?
So let me take a stab on this question.
Sure, thank you, Martin.
And one thing we have seen as the pandemic kind of settle in, and people start accessing or have the need to access remote access tools. One of the first things they tried to do was to extend the IT corporate tools into the OT environment. And I will say that if your process is not critical, that might be okay. If you can wait, 5 minutes from the time you log in or until the time you actually access the PLC, if that's okay, for your process, I will say that, you can continue doing that. But we have seen specific requirements for remote access into OT environments where they need to have almost immediate access into the asset. Just imagine if you have a crisis in a tank that is pressure is increasing or temperature, which has the potential to explode, you might want to get to that asset pretty quickly to troubleshoot the situation. And that might require different ways of connecting into the device. We have seen specific purpose-built tools for OT environments to enable that kind of remote access. And that also comes along with things like, in the traditional IT environment, people can connect anytime they want. They don't even have track of the activities they are doing. You don't have the capability to record the session. And if you do you require a lot of resources. In the case of the OT stakeholder, some of those tools can actually enable you to track activities, and people are not connecting into the environment until you actually issue a token. So you kind of give them a token, and at that time they only have like an hour to connect and do their troubleshooting. So I will say that in addition to the typical traditional VPN way of connecting into remote assets, there are additional solutions that vendors have developed in the last few years to tackle the specific use cases for OT stakeholders.
I'm going to move to another question here. We've got one on component level security. So I think this is from Moises Salazar. And the question is component level security enough like Ignition? I'm assuming we're talking about Ignition SCADA. I don't know, Martin or Rakesh, if you're familiar with Ignition or the architecture, but this question of security of the application or of that stack versus security of the overall network and architecture. Can you rely sort of on an end-to-end approach versus locking the network down, for example?
I'm not familiar with it, so I probably can't answer this question.
Okay, could be we're not familiar enough with that architecture to speak to it. There's a question on trust, and I think this goes back a little bit to questions of supply chain as well, from Brent. And this question is on how we ensure trust with enterprise network devices manufactured in China or in other countries where we may not trust the standards that the companies may be following there. Do you have any thoughts on how to mitigate that either in the procurement level or in the network architecture once you've deployed devices? I can
have a discussion about what we have built at technology, and so Intel developed something called secure device onboarding, right? So at the time of manufacturing, the device is enabled with SDO, and now it is actually called FIDO device onboarding, FDO. So rather than asking the manufacturer to put the full software stack on the device, we just enable the device with FDO. And then as the supply moves to the supply chain, the ownership of the device is transferred from the one owner to the next owner. And it goes all the way to the final owner, who then decides what he wants to do on the device. He wants to onboard it with an operating system or provision with an operating system, and then with lifecycle management services and orchestration services. So all of this is done by the owner. So now he knows not only his software is protected, he didn't have to send it to the manufacturer, but he installs it himself and then locks down the device and uses it. So that's one approach someone can use. And all of this is open source, by the way. So you can actually get the software I just mentioned, HDO, FDO, Google it and you'll find it.
Got it. So it sounds like that's really a technology approach for new systems that can help mitigate some of these concerns. Martin, do you have any comments on the supply chain or trust issues with equipment or application vendors?
Yeah, one kind of a use case or application we had was to perform a risk assessment across the supply chain vendors, and really goes down to understanding what are the things and how they actually, what procedures they use to build up their technology and what security they have built into. And so in that case, we use the 62443 standard and apply that across the supply chain, looking at the component level, because there is one standard in the 62443 that looks into how you build the overall solution with the components. It has a lot of controls that you can actually apply, and it's obviously recommended to only apply the ones that are more applicable to your application. But after you move out of the control, the component at a specific level, you look into the overall system, and then you look into the overall application. So there are like 3 different layers where you can look into, and there are specific recommendations for each of the different layers. So I will recommend to look into that part of the 62443, which really expands and touch into a lot of very specific procedures on how to perform that kind of assessment.
All right, thank you so much. And I think we're going to wrap up our Q&A session. We've more or less reached time here, so we're going to finish up our session now. So thank you to our speakers, Martin, Rakesh, and Paul. Thank you for your amazing insights today and your knowledge. Thank you again to our sponsors, Hitachi Vantara, HiveMQ, Siemens, Fortinet, Keyfactor, EMQ Technologies, K-Factory, Ovisi MBT, Trend Micro, Faircom, Nozomi Networks, LIM CMMS, Adolis, and Raven. Your support ensures we have all this great content to share. Thanks to our attendees for listening and for your great questions. And now it'll be time to move into the next session, and it'll be on cybersecurity for manufacturing. So great to see the cybersecurity track continue, and it'll have more great panelists. I know some of the panelists, it'll be another great session. So thank you very much and have a great day.